Hi, good morning, everyone. I know you can hear me. So, welcome to our GAIAthon webinar series. And this is the ninth session. And today we have an exciting topic on getting started with Copernicus Data Space Ecosystem, tackling environmental changes in Africa with free data and processing power. And I can see the speaker's face, András Zlinszky, who will be our speaker for today. András is the community evangelist of the Copernicus Data Space Ecosystem, and he has a background in ecology, earth observation, and science communication. He worked as a researcher mapping historic changes of wetland ecosystem on Lake Balaton, applying airborne LiDAR to ecological mapping at various scales. And is also contributed as an expert, EU expert, to the development of satellite-based agriculture monitoring in Hungary. And he was involved as a limnologist expert in the ecological art projects of the Vesperen Balaton European Capital of Culture 2023. And now his current work focuses on training, outreach, and content development for the Copernicus Data Space Ecosystem. And his mission, that is why he calls himself an evangelist. His mission is to make satellite data accessible and actionable to everyone, including us.
Thank you for the kind introduction. I will start. So the Copernicus program is actually a program of the European Union to support evidence-based policy. So the most important application of Copernicus is to support environmental policies, societal and climate policies with data and information. And as part of this program, we have launched a scheme of satellites. So we have Sentinel 1, 2, 3, 4, 5, 6. And in addition to these satellites, we are providing services which are generating data sets that can be directly used to support decisions and policies. So the first one on the list is Sentinel-1. Sentinel-1 is a radar satellite. It works with 10-meter resolution, and it sees through clouds. So it can actually provide information on vegetation condition or landslides or floods, even if the weather is cloudy. Sentinel-2 is an optical satellite. This is mainly looking at vegetation. So the main purpose of Sentinel-2 is understanding agriculture because it works really well for categorizing vegetation or understanding changes in plant growth. It also has some bands which allow the detection of fire. You will see that this is a useful application of Sentinel-2. It collects data every 3 to 5 days. And the spatial resolution is 10 to 60 meters, depending on which band. Sentinel-3 is mostly used as, or called as, the ocean satellite. So this satellite monitors water quality, but it can also collect very detailed information on vegetation condition and status. And Sentinel-3 is collecting data every day. So it images the whole Earth every day. You can have an image every day if it's not cloudy. Sentinel-5P is the air pollution satellite. So this satellite looks at air quality. It looks at the atmosphere. Of course, it also measures clouds. So parameters such as air pollution in cities or the effect of forest fires or volcanic eruptions can be followed with Sentinel-5P. Sentinel-4 is a weather satellite. It's not launched yet. It's coming. Sentinel-5 is the follow-up of Sentinel-5P. So that's also an air pollution satellite. And Sentinel-6 maps sea surface temperature and sea surface height topography. This is also used in ocean applications, but rarely in Copernicus Data Space Ecosystem. So we have all these satellites. And now the question is how to put this into practice. How can we make something from the data which is actually useful, which is actually helping people's lives? What I am showing you is agriculture monitoring in Slovenia. So in the European Union, we have a scheme of agricultural subsidies. Every farmer is paid some money for the farming and for the compliance to regulations. But the areas that they farm, the farming plots are checked every year using satellite data. And what you see on this image on the map is an area is green if all the parcels inside have been checked, and every farmer is doing what they should. And the area is marked yellow if we are uncertain, if we are not sure whether the farmer is complying to the rules. And as we move through the year, through the vegetation season, we collect more and more images. We have more and more information. And in the end, we come close to being able to certify all the farms in the country. So this is a very large scheme. It involves classification, time series analysis, data collection from farmers, field mapping. But this is a real-world operational application of Copernicus data. This is the type of applications that the Copernicus program was built for. But we have a problem here. Satellite data are big. They are not so easy to access, right? So the first step, of course, is downlinking the data from the satellite. The satellite collects the images. It is sent down via a radio link, and it's stored in servers. And then the next thing that happens is you want to create some sort of an analysis, some sort of a study. Like what we have here is a time-lapse map of a volcanic eruption in Stromboli in Italy. So before this map can be generated, of course, the images have to be stored on the server. They have to be corrected. They have to be labeled for quality and cloud effects. And then you query a small part of the image. And for this image, you apply an algorithm. And this is going to be the analysis product that you see. The output product is this little file, this time lapse. And then if you want to do some quantitative analysis, if you really want to reach some numeric consequences, you want to visualize the result. You want some sort of a chart or some sort of a table or a graphic result. And then the end product is displayed on your computer. Now, the big change with Copernicus Data Space Ecosystem is that practically all of this process is taking place in the cloud. So on virtual machines, on services provided by the Commission. Your computer is just an interface. It's the tool for telling the server what to do, but you don't have to download the data. You don't have to work with big files or large algorithms on your own computer. It's just an interface. It's just for communication with the server. And everything, the data accessing, the processing, and the visualization all takes place on the server, not on your computer. This is what Copernicus Data Space Ecosystem is about. So you can think that a good data platform will move a lot of data, but no, we think a good data platform avoids moving a lot of data. It creates the data, it does the analysis, and it only sends you the end product. This is what Copernicus Data Space Ecosystem is about. So at the heart of the data space, we have Sentinel data. So I showed you the satellites. All the data from these satellites is immediately accessible in Copernicus Data Space Ecosystem. There's no more waiting for a rolling archive or for a data download. And in addition to Sentinel data, we also have Copernicus contributing missions data, so high resolution data from selected areas. And we also have additional Earth observation data like terrain models or downstream data products. And for accessing these data sets, we use APIs. Now, what is an API? An API stands for Application Programming Interface. It's a machine-to-machine interface. It allows your computer to communicate with our computer, the computer that's storing the data. So you can use a common language, an interface to define a processing task. And this is going to be sent to the computer which holds the data. The processing is done over there, and then the result comes back to you. And all this is done inside your code. So you don't have to work with specific software on your computer. You can add the request and you can run it straight in the cloud. And so combining these data access requests and Sentinel data, we have the Copernicus browser. Copernicus browser is an easy interactive interface for looking at satellite data and doing small analysis tasks. It works with the APIs. It's actually an interface to control the APIs. And of course, it's links to the data. This can be used in schools by children, but it can also be used for highly professional applications. And then we have onboard code repositories. Now, coding in Copernicus Data Space Ecosystem is a bit special because you don't have to take care of the data management because that's done by the infrastructure. And you don't have to take care of the visualization because that's done by the front end. So your coding can actually focus on the application that you are developing. And to make this even easier, we have a big code repository with many, many examples that I'm going to show you. So it's easy to take some building blocks and put together a pipeline that will run successfully. And we have cloud computing capacity. So often the problem is really, where can I process my data? Where can I find a big server that's going to run this? And now the Commission decided to provide cloud computing capacity for free. So you have quite a generous quota. You can define a virtual machine and you can run your code over there. And combining cloud computing capacity and these code repositories, we have code labs like a Jupyter Lab and also graphical interfaces to coding like OpenEO and the request builder. So these are the places to start hacking and to get working with the data. Now, of course, not all the data in the world is stored in Copernicus Data Space Ecosystem. There are other cloud storages out there. But in many cases, it's possible to federate, to connect one data space to another data space using Copernicus Data Space Ecosystem. You can pull in data from an external source and add it to your pipeline, to your workflow, combine it with Sentinel data by using our identity services. And then we also have a traceability API. So it's possible to do a small check on any satellite image or data product to check whether the image is fake, whether it has been tampered with, or whether it's actually a genuine data product. So all these individual functions put together, this is Copernicus Data Space Ecosystem. And we hope that upstream providers, imaging companies will join. And we also are seeing more solution providers, downstream data provision companies joining the ecosystem to make this a common platform for data sharing. Okay, once more explaining the API access part. So the old way we used to do this is that the data is available in a predefined set of tiles. This was because the data needed to be compressed. So the data is compressed into tiles. You select which tile overlaps with your study area and you download that. And also, most of the data was stored on a tape archive. So the last 2 years were immediately accessible, but the archive data had to be queried. You submit a request, and then maybe 2 days later, you get the data. This is not the situation anymore. Okay? Then when you download the data, you have to store it on your side, and then you have to move it to a powerful machine to process it. So if you want to work the download-based way, you probably have to pay a lot of money to buy a big computer, and you start small. But if you want to grow it to work on a large area, you will have to buy an even bigger computer, so it's difficult to scale up. Now, this is what has changed with APIs. So the data is immediately available for your area of interest. It's not compressed anymore. We are using a format that allows directly querying the data without putting the file into the memory. All the data sets are immediately available. You don't need to store the raw data on the client side because it's stored on the server and you can tell the server directly what to do. You are using virtual machines which already have the data on board, the same machines which already have the data. So you don't need to invest a lot of money to get working, and your system can grow as the demand grows. This is the big thing with API access. Okay, Copernicus browser, we are going to look at it quickly in a hands-on. But just an overview of the functions. So this is for searching and downloading all the data products that you can get in Copernicus Data Space. It provides a really nice visualization interface. So you can look at the data collections in true color or in other composites. You can also create an export. So if you want to create a print for your wall, or if you want to download a data set to work with it in QGIS, or just a small image to share on social media, this is here in the download functionality. And you can create comparisons. You can look at quantitative properties of the data. You can ask for a time lapse or a histogram of a specific study area. And it also works in 3D. So it's possible to take a look at scenes in 3 dimensions. And this also includes comparing various properties of an image. Okay, then we have these code development interfaces. So Jupyter Lab is an onboard virtual machine that allows you to work directly with the data without having to install anything on your computer. Jupyter is a really nice way to work with Earth observation data now, we've found, because it's a combination of human readable code, like Markdown, the code that you actually operate for processing in Python, and pictures or maps, visualizations of the products. So if you change something in the code, then your map is going to change. So it's very, very interactive. And when you are finished with your processing, you have it all in a Jupyter notebook where everything can be nicely explained, and you can share it with somebody, or you can push it to a different server to run it. We have tutorial notebooks for several use cases, air pollution or ice monitoring or time series generation, and you can start experimenting with these and adapt them to your needs. And we also have the OpenEO interface, the OpenEO web editor. OpenEO is a specific API. Remember, API is an application programming interface, a way for your machine to communicate with our machine. OpenEO is not dependent on a specific data format or a specific coding language. It has its own data cube format, and it can work with R or Python or Julia. So this means that it's very easy to build code from pieces of other people's code. And it also runs super efficiently. It's very scalable. So you can work with it, and it has a graphical interface, which you see here, but it also works in Jupyter Notebooks. If you are developing something that has to run commercially and the open quota of the data space is not enough for you, then the next step is going for a commercial cloud provider. GAIAthon' is a commercial cloud provider which already has all the Copernicus Data Space collections on board. And it also has the full code base on board. So this means if you develop something on Copernicus Data Space Ecosystem, it's very easy to take it over to GAIAthon' and to run it there. This is not a free service. This is a commercial service, but we also have a program for credits for value creators supporting new applications with a certain quota. So, I mean, we have the materials for a big change in Earth observation. I really hope we are making it very easy to access Earth observation data now. So what we need are building blocks. We need you to share the data sets you create, to share the code you create, to provide us with use cases, because we think that this platform, Copernicus Data Space Ecosystem, is the right place for collaboration. It's not owned by an industry company. It's not taking ownership of your data or your code. It's not locking you into a specific set of tools or functionality. Since it is public, it's open, and that means that it's really, really there for everybody to work with. It's really a standard. So Copernicus Data Space Ecosystem is this free public platform for Earth observation-based solution development. It's possible to share your data sets here. It's also possible to access the already available data sets. You can create analysis tools which will run in Copernicus Data Space Ecosystem for a long time, even operationally. Copernicus Data Space is actually governed by a service level agreement. So there is a very strong agreement in place with the European Union that this system is going to run in the same way for the next 6 years. But we hope to extend it for 10 years. So that means you can trust it, you can build a solution on it because it's going to be there. It's not like a commercial provider which can change from one day or another. I hope that Copernicus Data Space Ecosystem is a transformative solution. So a solution that's bigger than the sum of its parts, that has a larger impact than its individual components put together, because now we are enabling much better sharing of code, we are enabling virtual machine processing, and we are opening the whole central archive. So this is my introductory presentation to Copernicus Data Space Ecosystem. And now let me show you how the data system works. This is our front page, dataspace.copernicus.eu, and I am trying to put the link in the meeting chat. Yes, here we are. Okay, the link to the main page is here in the chat. You can also open it up on your computer. So what do you see here? Here's just a news carousel, which gives you the most important new features. This is a description of the services. We have a news page, which I'm going to show in a bit more detail. And here is the roadmap for upcoming future developments. So here under news, you can see every change or every notice. Sometimes we have a maintenance period for a satellite. Sometimes we are advertising some new functionality that you can get working with. And sometimes we are also sharing blog posts, which are like detailed descriptions of a specific application. So this is a page to start with. The front page also has a gallery, so a collection of images of interest with a short description. This is just a resource for starting to learn about Earth observation or finding interesting pieces of knowledge. We have a collection of use cases. We also have a list of events that we are attending to. And we have a scheme of videos. We also have our own YouTube channel. So if you are new to Copernicus Data Space Ecosystem, click this green button here and register. You are going to need the registry to also work with the Copernicus browser. Here we describe our data collections, our different tools for data analysis, and this is where service providers in the ecosystem are available. Under here, the support machine or button, This takes you straight to the documentation portal. So this is where everything is described in detail, where you can search for a specific functionality and find code snippets or examples or just directions on how to work with it. Here's our community forum. Again, a very, very good resource, actually a super active forum where questions are answered relatively fast and many different topics can be addressed. So you will easily find information about your questions, or if you come up with something new, then we really hope that the CDSE staff typically answers very quickly in a couple of hours. And it's also possible to submit a support request. Okay, now from this main page, I will show you how to get started with the data. So hopefully you have registered here. And now we move over to Copernicus browser. Just click this button, and this is what you will see. Again, I am sharing the link here. So this is Copernicus browser. This is our interface for application development and satellite data viewing and analysis. And it's also possible to generate small data products that will work inside this browser and be accessible to everyone. So what you see here, first of all, this is where you can set your language. We have a couple of languages. A French language interface is also available. And then the background that you see here is a Sentinel-2 mosaic. You can also change the OpenStreetMap if you want some more information on places to see. But right now I'm switching back to the Sentinel-2 mosaic. So this is a data set that's generated from our full collection of Sentinel images over the course of 3 months. It's a cloud-free mosaic, and this means you can look at very, very large features. You can explore across large distances without having the interference of clouds or swath edges. Right? Now here we have a configurations menu. This is the default configuration. This is what you use for looking at datasets, but we have some themes where you can already look at example datasets. So if, for example, here I click agriculture, I get a collection of images relevant for agriculture. And if I click one of them, it takes me to that place and it gives me a bit of an example of what I am seeing. We're just waiting for a second to load. So this is a near-infrared false color image. But in addition to these examples, if you just click the green button, which is show latest image, here you have a collection of data layers specific for the application that you are working on. So now it's agriculture, and we have true color, false color, NDVI. We have a bare soil index. We have a moisture index. We have a composite for agriculture. So if you're completely new to Copernicus Data Space Ecosystem, I recommend that you start here. You explore these configurations and you explore the individual place marks that come with them. Right? This is a Sentinel-1 image, a radar visualization. Because again, in some cases, if you have a flood, then you don't see much in optical images due to the clouds. And here again, we can query the latest images. We can see the data collections that we have here, Sentinel-1 or Sentinel-2. And we have a set of data layers optimized for this particular application. Okay, now let's move back to the default configuration. Let's find an interesting place. Right now, I'm just going to Nairobi, and I'm loading the latest satellite image. It has some clouds, but you can see the main features of the city. Let me quickly show you how to share a link, and then you will be able to work with sharing links. So if you just click here, share, and you click generate, then here you get a short link. And if I paste this over here and you click on that link, you will see the very same place in your own browser. You will be able to open up the same place. Okay, over here, we have tools for creating an area of interest. We have tools for creating a line of interest, for measuring distances, downloading images, creating a time lapse, looking at things in 3D. I will just move over to a different place of interest. I'm going to Lake Naivasha. And so here is my latest image from the 27th of April. This is my distance measurement tool. So this lake is 16.5 kilometers across. This is where I can mark a place of interest so that I can find my way back if I zoom out. And now we are going to get into quantitative analysis. Right now, I'm using Sentinel-2 data. So I can show you how this works. If I create a small area of interest here, like this field, and I click here, this is Spectral Explorer. This is showing me the values of the individual spectral bands where Sentinel-2 is doing its measurements, right? So band 2, 3, 4, these are the red, green, and the blue bands. And then these are the near-infrared bands that provide the reflectors of vegetation, and this is a short infrared band. Now, if I want to look in more detail into the vegetation, I can use the NDVI product. This is a product that shows us the vigor or the greenness of the vegetation. And if I click on the histogram, this gives me a histogram of the properties of the vegetation inside this area. So see, most of the vegetation has an NDVI of 0.8. Again, I'm going to share a link so that you can go to the same place if you've maybe lost track. Right. Here we go. And I can actually also copy the coordinates of this little area of interest here. If you just copy and paste this when you are generating an area of interest over here, with this upload button, you will come to the same place. And now, if I click on the statistical info tool, this is giving me a time series. So for the last 1 month, the mean and the standard deviation of this parcel looks like this. Now I'm going to remove the cloud cover. I'm only looking at images which are cloud-free. And I'm moving over to a longer time series. And so here I have 6 months of this vegetation index, right? And it's possible to export this directly as a CSV. Now we are going to look into the engine room for a moment. If you click on this little code button here, then this is the actual code that's running for the visualization. It's called the eval script or the custom script. It takes band 4 and band 8, which is what it's using for NDVI. It's using the scene classification layer for the clouds. It's outputting the default output, which is a colored visualization and some statistical indices. And then it applies this index. This is NDVI itself. It initializes the image. Here's the palette with red, green, blue, and transparency images for individual image values. And then this is the data set it returns. Right? So this can actually be edited directly here in the code. If I would want to use band 3 instead of band 4, I would be able to change this. And I can click apply. So now the result is slightly different. And we have a repository of these codes. So over here, this is the Sentinel Hub custom script repository. This has over 100 different scripts for various applications. And each of them has its own little page with an explanation, a description, some sample images. And the code here can be just copied and pasted back in here. And then you will have a different visualization, right? So if you want to experiment with Copernicus browser, you can explore these codes. You can also create new ones. If you create something that works well, I suggest that you send us a pull request, because this repo is on GitHub, and then we can feature and share your contribution. Oh yes, a time-lapse image. Time-lapses are generated with this little tool here. Okay, I have to close the area of interest. So this is my time-lapse tool. I can set my time of interest. and then it's querying all the images from the area. And then I have a little animation, a little movie. And I can download that. Okay, now, so much for Copernicus browser as a very brief introduction. We have some really nice further detailed tutorials here on our YouTube channel, actually. YouTube Copernicus Data Space Ecosystem, where we explain advanced use of Copernicus browser and the application of the browser for various different fields of science. So what I want to show you now is the Jupyter Lab. This is how you access the Jupyter Lab. If you go over here, Analyze Data, Jupyter Lab, access Jupyter Lab. Again, I'm pasting the link in the chat. And also the link to the custom script repository, actually, just so you find it. So you have to click Access Jupyter Lab. And then this here is a small online server, a small virtual machine that you can work with. And here in the samples notebook, you have many different samples for various applications. But here is the Sentinel Hub example folder. And here I'm going to show you a very quick introduction to Sentinel Hub APIs. So this is a notebook that helps you get started with Sentinel Hub data or Sentinel Hub APIs in Copernicus Data Space Ecosystem. The way a Jupyter Notebooks works is this is a markdown part. This is a text with code. And these code cells can be run when you just click in the cell and you hit Shift Enter. And then it runs. Here's a little star showing you that the cell is running. And then when it's finished, a number will pop up. And so in this notebook, you learn how to handle your credentials. So creating something like a password inside your code, how to set an area of interest, and how to query the data sets that are available for that area of interest. This is called the Sentinel Hub Catalog API. It allows you to query data from a specific place and tells you how many images are available for that specific place. And then this is how you actually create an image. It's also a way to download images in bulk. If you need to download a lot of images, it's probably best to go through the Jupyter Lab and the Process API. So first here, you set the custom script. This is the very same way as we set the script over here. So actually the scripts that we have here in the repo are going to also work here. This is just a true color image where we use bands 2, 3, and 4, and we don't even apply a scale factor, we just return the same images. And then this is the API request where I am telling the server, this is the eval script I'm doing, so the processing that takes place on the server side, what data collection I'm using, what my bounding box is, what my data size is, and how I'm configuring my credentials. And then if I run this request, I'm going to get an image. And this works the same way if you add a different eval script. So this here is the same NDVI custom script that I showed you in the browser. And then you create a request which refers to this eval script, and the result is an NDVI image. And additionally, you can work not just with images, but you can also generate statistics, so numbers, directly here in the API. Instead of downloading and working through many satellite images, you can go straight to the statistical API where you specify your area of interest. So this is the very same thing we did here, right? I make a small area, and then I look at the time series. And this can be done directly in code. You define the eval script. Here it's NDVI again. You define your area of interest in code with these polygons. And then you run a statistical API. And with the statistical API request, you specify your time interval. So between these intervals, all the images will be queried, all the images will be explored, and you're aggregating the data, in this case, in 10-day intervals. So I am looking at NDVI in 10-day intervals on the Sentinel Hub statistics API. And my output is going to look like this. So the output is a JSON. It's a structured file, which has the parameters min, max, mean, standard deviation, and sample count. And if you apply a little helper function here, you can load it to a pandas data frame. And with this data frame, it's possible to visualize it directly in the Jupyter notebook. And then you can actually reach this level of information where you are taking data directly from the satellite image without downloading anything and visualizing it in the Jupyter lab. We have many different tutorial notebooks. Again, we have different use cases on erosion risk or fire monitoring, actually also data access from different portals. So here we are integrating data from the ERA5 climate repository and Sentinel data. And all these example notebooks are here for you to explore and get started with. There's another source of examples I want to show you here, which is the OpenEO community examples folder. So here you see many, many different folders, many, many different examples of how to use the OpenEO API, not the Sentinel Hub API, the OpenEO API in code. And this one also contains advanced machine learning. It has an ONNX folder here, yes. So ONNX is an interface for working with deep learning models. And this means you can actually apply a deep learning model inside an API request on Sentinel data using OpenEO. Yes, once more, I want to point you to the YouTube channel. Actually, this is where we explain, where we recently explained machine learning using OpenEO. Yes, here, this one, in Copernicus Data Space Ecosystem. And this is our forum page. I'm going to stop here to leave time for the Q&A, but please don't hesitate to ask questions, and I will be here and try to answer everything I can. Thank you for bearing with me.
Thank you very much, András, for this insightful and heavy-loaded presentation. And before we start a Q&A, I want to inform you that we'll do our very best to put this presentation on our YouTube channel that you can go over it again. So please, we open the floor for your questions. You unmute yourself, you ask your question, or you raise your hand, you ask your question. Or you can also type into the chat window, and András will manage all. So the floor is open for us. But before we do that, András, I think if the students want to access this data, they have to first register, isn't it? And how long will it take for approval, and then they will start using the resource that is available? Because with the GAIAthon that we are running now, they will need to use the data when they have been selected into the final stage. They will be pitching by next week, and then we'll select those who will go into the finals to start using EO data also with IoT. And this is a very great resource that they can use for their solution. So registration, accessibility, what is the time frame?
That works immediately. So when you register to the data space, you can access the data straight away. There is one small set of data, the Copernicus contributing missions data, so the high resolution data sets, that requires an approval. That can take a couple of days. But I think the CCM Copernicus contributing mission for Africa coverage is quite limited anyway. So you would want to work with the regular Sentinel data or the downstream Sentinel data products, and then your registration will be live immediately, and you can go and work with the data.
Okay, so please, you can manage it better. Sydney William, who want to ask a question?
Thank you very much for the opportunity. Please, I would like to know how this Earth observation data can help us improve agriculture. What's the significance of this data in improvement of agriculture? Thank you.
Let me show you a couple of very quick examples. So right here, what you see, this is KNDVI. So this is the vegetation index. It tells us about the health and the vigor of data. So crops that are more productive would have a higher KNDVI. And this means that farmers can explore their crops and see which fields are performing better and which fields are performing worse. This also means that patches inside fields can be recognized. So you might be able to reorganize the layout of your field to account for changes or differences in water availability or soil quality, or apply different fertilization rates depending on what you expect from one patch or the other. Like this area is specifically quite fertile. This is a good area. These places are a bit worse. And then the farmers can look at the data and take this into account. Then there's another application here, which at least farmers in Europe like a lot. This is the moisture index. So this is directly available from Sentinel-2, and it tells you two things: whether your plants need irrigation, how dry they are, and the other thing is whether your crops are ready for harvest. So a lot of the crops need to be harvested when they are actually quite dry, grain crops. They are best harvested when they are dry, because otherwise you have to dry them afterwards. And then this will tell you how to optimize the planning for your harvest. Then we also have from Sentinel-3, we actually have some calibrated vegetation products. So I hope I get the cloud-free image. Yes, so OTCI is a chlorophyll index, which relates very specifically again to the health and the vigor of your vegetation. And GIFAPAR is another vegetation index, which relates to the vegetation structure, the amount of biomass. And these can be used to follow the development of parcels. Then there is also a way to explore land cover using Sentinel-2. Actually, we even have some global land cover data. So in relation to agricultural statistics, it's possible to map the different crops that are grown in a specific area, and then you have a bit of a better knowledge of what people are producing. This was just a very, very short overview. There's a lot of literature on the application of satellite monitoring for various fields of agriculture. Let me check the questions from the chat very quickly. Downloading the data and working with it from a remote place. Yes, this is also possible. The easiest way to download data is through the search tool in the browser. So if you use the search tool, here you can select a time frame, you select the satellite, you apply a cloud coverage filter, you can filter for the satellite platform, and then you just click search, and you will see the outlines of the satellite datasets that are available. So these are a couple of image tiles, and then you should be able to select these individually. And maybe if you're short on web coverage, then you can even download individual files, only the files with, for example, a specific channel. And if you don't want to wait because you have to download a lot of data, then what you do is you add it to your workspace with Add to Workspace. And then over here, you can go to your workspace. So this is workspace.dataspace.copernicus.eu. And then here you will have a list of files, and you can just click on all of them, select all of them, and then click download. And then maybe you have to wait a while because you might be downloading 100 data products, but they will be all there then on your downloads files. So this is how to access many data sets at the same time through this interface. It's also possible to download data directly in the API. Actually, it's more efficient. So using this little notebook here, the data access and process request notebook, you should be able to find a way of how to download that data directly with an API. And again, this allows you to download the data which is pre-processed using specifically the algorithm you want. Let me give you the link to this notebook as well. This is our GitHub repository, so you will find many different notebook samples here, but also actually the code for the browser itself, the browser front end is open, so you can explore that as well. I'll just give you the link to the data downloading notebook, data download process request. Yes, here it is. So you can look at the code, you can explore it, or you can run with it. Carbon footprint. Carbon footprint is a bit of a difficult question because it depends on many different things. So it depends partly on land cover, land use. Data on that is available. So if I just go back to the visualize panel, we have a global land cover data set, and more data sets are coming in. So this is one of the data sets that you can use for carbon footprint calculation, but it's also possible to access data on air pollution. Let me again find a place where we expect a bit more air pollution. So here I am at Dar es Salaam. Sentinel-5P data are a daily data set providing information on air pollution. So this also includes carbon monoxide, which can be used as a proxy probably for all carbon emissions. And then it's possible to use data sets. And again, you can create a time lapse, you can create an area of interest, or you can download it actually to do a long-term analysis. But otherwise, for more detailed carbon footprints, you will have to take this data as an input with land cover or with seasonality or human settlements, but you have to calculate the carbon footprint file or the carbon footprint approach yourself. Using the data in QGIS or ArcGIS, yes, this is possible as well. I'll show you the easiest way. So if you go to the main page, here you have your Sentinel Hub dashboard. And then in this dashboard, you have a configuration utility. And this allows you to create new configurations. A configuration is a combination of data sets. So, for example, here's a configuration. Configurations have layers, and these layers each refer to a data source, which you can specify here, and the visualization or processing tool, which you specify again from the custom script repository using the JavaScript code there. You can restrict it to a specific time range. And then once you have this configuration, here you can actually create a WMS endpoint. So if you have used WMS in ArcGIS or QGIS, you can just copy this URL and you will add it to the settings menu in your software, and that will allow you to work with it directly. There's also a QGIS plugin. Here you go. We have a blog post on this. I'm just copying the link here so you can explore, but this allows you to directly open up the data inside Copernicus Data Space, inside QGIS. It's not going to be the shape files, it's the raster files. Well, Copernicus Sentinel information for a specific country. Again, I would go directly through the browser in the first case. So changing back to a different data source, first of all to Sentinel-2, adding country borders. Just a second, I'm going to use the OSM background again. Yes, here we are. So here's Ivory Coast. I go back to the Sentinel-2 mosaic. And then for this area of interest, you can use the search panel and you can define a new search to check what Sentinel-1 or Sentinel-2 or Sentinel-5 datasets are available. Again, another nice data source is the mosaics. As I told, these are seamless, but they don't cover the whole world. Unfortunately, the Sentinel-1 acquisition is not available everywhere, but here for Ivory Coast, it's available. So this is the first place to go just to explore the data availability. Okay, any more questions? Does someone want to say their questions live?
Yes, thank you. Please, I'd like to know if it works accurately for smaller farms. The Earth observation on agriculture does it work accurately for small farms?
For small farms, well, the spatial resolution is the highest spatial resolution you get is 10 meters. So with Sentinel-2, there is some limitations. It's not going to be extremely high resolution, but the information is not really in the spatial resolution. Of course, delineating farm parcels or exploring the parcels that belong to a single person might be difficult because the resolution is not that good. But you can look at things like seasonality using the time-lapse tool, or even explore the agricultural growth stage, and that's going to provide information even for small farms. Let me try and give you an example. Again, we are using the custom script repository. So here's my little code. This is agricultural growth stage. So this looks at the stage of NDVI growth. It finds you the time of the NDVI peak. And if we go back to the browser and if we select a time frame, so here, this is not for an individual image, but for a time frame of several months. Then I can apply this script. Hopefully it's going to work. Yes, and this is going to give me information about the growth stage for individual areas. It's not perfect because again, it's influenced by clouds and it's influenced by the strip pattern of the sensor, but it's a way to look into vegetation patterns for different places, and it also exploits the high resolution of the imagery. Let me see some more questions. How to combine different map layers for visualization? You can use the compare mode. So that's again the easiest. If you just click, let me go to a different place to see something a bit better. I'll go up to the Nile Delta in this case. So just going back to an individual data and looking at the imagery, I can add a scene to a compare. So if I just click add to compare here, and then I select an image from a different time or a different visualization, then here I have an overlay of different data sets. Takes a minute to load again. Okay, should be like this. So this way you can visualize data sets one above the other, but you can also do this in code. So it's possible to create a custom script which combines several layers with different levels of transparency, and then you can actually explore them individually or set their transparency. This is something you do in JavaScript code. Yes, here's my compare. So like this, see, you can add several images to the map. You can combine these different layers, and it's also possible to share this using the share link, and then somebody who is already registered and in the browser will be taken to the very same area. Pulling the data to an app. It's possible to add CDSC data to a web GIS. We have a blog post on this. Let me check. Integrating satellite imagery into web applications. Yes, this would work. But you can also go directly through the API request. So it's possible to embed the Sentinel Hub or OpenEO API request into your code that runs on your side. And then you would be able to show the data directly inside an app. Tree height or vegetation cover. Well, tree height is complex because it depends on many different factors. Of course, vegetation greenness or vigor is one thing, but it's also possible to look into tree properties using Sentinel-1 data. Let me find you a place with more trees. So Sentinel-1, the reflectivity you get from Sentinel-1 also depends partly on the vegetation structure. This might be a good data set to explore. We also typically use classical vegetation parameters such as NDVI. Or if you have a layout where the tree shadows are visible, then sometimes you can actually measure the tree height using the shadows. Real-time insight, well, the data is typically uploaded 24 hours after acquisition. For Sentinel-3, it's shorter. I think it's 8 hours. So this is the shortest time frame of data that you can get. For some people, this is real-time. For others, this is way too slow. But this is definitely the frequency of data that we can access. Copernicus Data Space Ecosystem works on mobile phones. So it's possible to create an API-based application that runs on a phone. It's even possible to run Copernicus browser on the phone. And there's a small thing here, the display wall. Show you this. This is a very, very simple front end. If you normally use it to run a slideshow, but if you just click on the edge of the image, and let me search for a place. Then you can directly load an image and move it around and explore the basic visualizations using a front end that's suitable for a touchscreen. So if you just want to show something quickly on a mobile phone, then maybe the display wall is the best tool. Oh, I've already pasted the link. Data on heavy metal pollution, probably not. You might be able to look at vegetation condition influenced by heavy metal pollution, or you can look at the effect of mine tailings. Let me show you a place in my home country, Hungary, where I know that heavy metal pollution is a thing. Hold on. So I'm going back to Sentinel-2. So over here we have an aluminium plant that is processing heavy metals. And then you can see how some of the soil is contaminated. It has this red color. So this is something that you should be able to explore. Maybe there's a way to see a bit more, because we had a pollution event. Oh yes, it was. No, you won't be able to see more in this case. Okay, any more questions? Yes, here's the red color of the soil. Okay, if there are no more questions, then I think we can conclude. I really, really hope that the resources I showed you, including the documentation and the YouTube channel and so on, will be useful. I hope that you can explore Copernicus Data Space Ecosystem, and I wish you a successful hackathon.
Thank you very much, András. This has been very wonderful presentation, and we know that the students are going to benefit from this. So Marco is an engineer at the Joint Research Center of the European Commission in Italy, and he facilitated the presentation by András. So please, some few words from you, sir.
Yeah, thanks a lot, George. Well, I want to thank András for providing the presentation. Indeed, very exciting. A lot of potential usages of this CDSC, which is now becoming more and more important for Copernicus and also for JSC and this contribution to Copernicus. heard about Tidiane attendance somehow to your initiative is very good, and we are, as you can imagine, through INPA, we are also very much in touch with AFSA for the type of activities. And so let me just wish to all the participants good luck. I think it's very nice initiative, very exciting, a lot of energy and dynamism about that. Don't hesitate to come back to Copernicus, to the DCAC, through the channels that you can find. And I wish you all the best for your efforts in looking at Earth observations.
Thank you very much,
Georgia.
Thank you very much.
Bye.
Okay,
Yeah.
bye to everybody.